Good evening, friends. Tonight is Unit 3, Lesson 6, and we are going to do some more multiplying with fractions, but tonight we're dealing with a special kind of fractions. They're called mixed numbers. So the first thing we're going to have to do is dig back in our prior knowledge of what to do with a mixed number, because we can't multiply a mixed number and a fraction. We need to have two fractions, whether it be improper or not. So the first thing I want to review with you is how to make this 1 2/3 into an improper fraction. I'm going to put little signs here and see if that jogs any memory. So what we're going to do is we're going to keep our denominator the same. We're going to go 3 times the whole number is 3. And then the whole number plus the numerator is 5. So 5/3 is the same as 1 2/3. So that's the first piece of information that we really need to build on, because I'm going to show you the area model and how the area model can help us multiply with mixed numbers. But the first thing you have to be able to do is think of your mixed number as an improper fraction. So I want to show you this problem here about a farmer. A farmer has a rectangular field, 1 2/3 mile long and 3/4 of a mile wide. So our problem is what is the area of the field? And we know, and so is our friend Melinda here, that to find out area, we have to multiply the length by the width. So 1 2/3 times 3/4. So she's going to explain to us, and this is all written out here, and I'll explain it with you, how she makes an area model to find this product. She needs to make a rectangle with the side lengths 1 2/3 unit and 3/4 units. So what she did, as you can see here, she first split the rectangle into vertically in red. So I'm looking at these marks right here. She did it in quarters. So here's a quart, 1, 2, 3, and then this fourth one here. So she shaded that in red. Then she horizontally, with the horizon, she did one whole square and 2/3 of another. So we had to divide it in 2/3. So she's got 1, 2, 3, 1, 2, 3, and she did one whole box and 2/3 of the other one. Okay, so it's hard to tell what this area is because you need to get this 1 2/3 down to a more manageable piece. So you see here you've got 5/3. So you've got 1, 2, 3, 4, 5. And I'm hoping I'm going to take a yellow here and see if you can see where she marked it up into thirds. So here's 1/3, here's 2/3, here's 3/3. 1, 2, 3. Okay, and then she did the quarters. 1, 2, 3, 4. And then the overlap, what I really want you to see is this right here. So I'm hoping that now you can kind of see that this is the area of what we were talking about. All of this right in here. And our unit fraction is going to be this box right here, which is equal to 1/12. So how many 12ths are in this overlap? Well, there's 15 of them. So the next thing we need to do is we need to find a number to simplify them. So I know that 15 divided by 3 is 5, and 12 divided by 3 is 4. So now I have 5/4. I know that 4 goes into 5 one time with 1 remaining. So 1 and 1/4 would be this area right here. Another example, and we're going to break it down into smaller pieces for you to digest a little bit. So now we're going to do this 1 2/5 times 1 1/2. So we're going to have 2 rectangles, all right? So here we're going to have 1 and some, 1 and some. So you're going to have 4 squares. So see, I want you to see this. There's 1, 2, 3, 4 squares there. You're always going to have buddy squares. You're never going to have an odd amount of squares. So if you end up having an odd amount of squares in an area model, you're not doing something right. So the first one is 1 2/5, and the very first thing we need to figure out is we need to make these mixed numbers into improper fractions. So the way to do that is this going to be over 5, and this one's going to be over 2. 5 times 1 is 5, plus 2 more is 7. And then 2 times 1 is 1, plus 1 is 3. So the first thing we're going to do is we're going to divide. As you can see, the red, she divided the squares in half. So here's a half, 2 pieces, and 2 pieces. And then she colored in 3 of them. And hopefully you can see that as the red. 1, 2, 3. Okay. Then she did these in fifths. 1, 2, 3, 4, 5. And we had 1 whole, and we had 2/5. So we're going to look at it going this way. 1, 2, 3, 4, 5, 6, 7. So I want to remind you of where our squares were. So here's the division line. And what we're going to be focusing on is this overlapping part right here. And these questions that we have here focus our attention a little bit. What unit fraction does each of the smallest rectangles represent? So what it's talking about is this little spot right here. So if we're looking at 1 square, we see it's divided into 2s and 5s on this way. So 2 times 5 is 10. So we're talking about each unit fraction is going to be 1/10. So each one of these squares is 1/10. All right. So how many unit fractions? How many unit fraction rectangles are in the overlap? So we're looking at our yellow box here. How many of these do we have in our yellow box? Well, 1, 2, 3 times 1, 2, 3, 4, 5, 6, 7. So I'm seeing that we should have 21 rectangles. So if we had to express the product of 1 and 2/5 times 1.5 as a fraction and a mixed number, we would have 21 tenths. And then if hopefully you remember how to do the opposite of make a mixed number, it's pull it apart. So how many tens fit into 21? We have 2 tens fit in there with 1/10 remaining. And hopefully you see that if you were to put all of these little rectangles together, you would have 2 full boxes and 1 more little tenth. Because each box, we decided, I'm just going to do this as your one box here, has 10 pieces. And if you count all of this overlap here, you've got a whole nother box and 1 extra one. So if we were to rewrite 1 2/5 times 1.5 as a product of fractions, is the product equal to the product of the numerators over the product of the denominators? Well, it would be 7/5, that's our improper fraction, times 3 2s or halves, that's our other improper fraction, would equal, does that equal 21 tens? 21 tens, why yes. Yes, it does already fit our already scheduled generalization. So let us look at an example, and I want to look at number 15. And I want us to, a bucket holds 2 3/4 gallons of water. The bucket is 5/8 full. How much water is in the bucket? So the problem that I'm hearing is 2 3/4. We want to know, it's 2 3/4 gallons of water. The bucket is 5/8 full. So what I'm hearing, what is 5/8 of 2 3/4? So the first thing that we need to do is we need to get an improper fraction here. But I want to take this 2 3/4 because that's going to help me decide how many squares I need. Because I'm seeing I'm going to need at least 2 squares plus almost an entire another one. So what I want you to see is I'm going to do 1 square, 2 squares, and then I'm going to do a 3rd square. All right. The first thing I'm going to do is I'm going to color in 2 3/4 of them. So I'm going to split them in fourths horizontally. So it's going to look like this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And where did she get the 4th from? That's where I got it from. Now, in order for me to know how many of these I'm going to color in, I have to convert this mixed number into an improper fraction. And the way I do that, remember, is the denominator multiplied by the whole number, which in this case would be 4 times 2 is 8, plus the numerator, which is 11. So 11 of these pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are going to be colored in. Then, vertically, we're going to divide it into 8s to find out. 1, this one's a little harder. 2, 3, 4, 5, 6, 7, and then I'm going to say 8. 1, 2, 3, 4, 5, 6, 7, 8. And in this case, I'm going to need to color in 1 row, 2 rows, Okay, so the magic here is in the overlap, remember? So my overlap, and it's kind of hard to see because my drawing's not all that awesome. It's going to be right like this. And if I'm looking at what this unit fraction is, this unit fraction here is 8, which is how many we divided it this way, times 4, which is how we divided it this way, which gives us 32. 8 times 4 is 32. And if I look at the overlap here, I have 5 times, so I have the 5 right here, 1, 2, 3, 4, 5 that we shaded in, times 11, which is 55. Now I have to change this back into a mixed number. 32 fits into 55 one time. I'm going to have some remainders. So I'm going to say 55 take away 32. I'm going to keep 32 as my denominator. Don't forget that. And it's going to be 23. So the answer to this would be 1 and 23 32s, 32nds gallons. So the overall picture here is seeing that overlap and seeing that now you're not just dealing with one square or one hole, you're dealing with more than one hole. You're dealing with 1, 2, and some more. It's not just one box. So that's the big difference with multiplying fractions. Is before you were talking about one box, one hole. Now you're talking about multiple holes. We will be revisiting this more tomorrow, so if you're not understanding it, we will have our mini lesson and small group work. Till then.